Hello students, Assalamu alaikum. Today we are going to discuss parametric equations. Earlier we used to solve or used to find, especially in differentiation, dy by dx, change in y with respect to x. Okay, so sometimes curves are defined parametrically. What do we mean by this? X and y are further dependent on some parameter t, and they are expressed in terms of t, right? So x is equal to 3t square minus 6t plus 10 and y is equal to 3t plus 8. So these are two parametric equations of a curve that is like given in parameter t. So we are asked to find out dy by dx. Find derivative, find dy by dx here. So we are going to learn how we are going to, differentiate x and y separately with respect to t and then apply chain rule to find dy by dx. So here you go. First of all, x is given, so we need to find dx by dt. In this case, that is equal to 6t minus 6, right? Similarly, when we have dy by dt here, that is going to be 3. Now, you say applying chain rule now. Applying chain rule. So now when we apply chain rule, it is basically dy by dx is equal to, it is dy by dt into dt by dx. You must have done it in AS. So here dt is the parameter, or we're going to use chain rule in terms of t. Okay. So dy by dx is equal to dy by dt into dt by dx. In question, we have dx by dt given. We calculated 60 minus 6. So now let's put these values in it. Now dv by dt is 3 and dt by dx, that is reciprocal of dx by dt. So this is how we do it, 60 minus 6, right? So that means this is 3 divided by 60 minus 6. That is your dy by dx in terms of t. And in many cases, examiner is going to, give you some specific value of t. For example, in this question, if we say at t equals to 1, find out dy by dx. So we have t equals to 1. You're going to substitute t equals to 1 in it. So 6, that's going to make infinity. So let's change it. For example, at t equals to 2. Okay, at t equals to 2, so it's 3 divided by, it's 12 minus 6, that makes it 3 divided by 6, that is equal to 1 divided by 2. That gives us that, okay, dy by dx is equal to 1 by 2 for this parametric equation. Okay. Okay, so here is a question. It's given that the parametric equation of a curve Rx is equal to 2 theta plus sine theta and y equal to 1 minus cos 2 theta. Show that dy by dx is equal to tan theta. We're going to, these are parametric equations, and then we have x is equal to 2 theta plus sine 2 theta, sine 2 theta. So dx by d theta is equal to 2 plus 2 cos 2 theta, because we know that sine 2 theta is basically 2 cos sine 2 theta is cos 2 theta into derivative of angle, that is cos 2 theta. Okay, and similarly this is dx by d theta we have. Okay, now for dy by d theta we have y equals to 1 minus cos of 2 theta. So dy by d theta is equal to 0 minus, now cos 2 theta is minus sine 2 theta into 2 into derivative of angle, that makes it 2 sine of 2 theta, that is equal to dy by d theta, right? So we have dx by d theta and dy by d theta. We are going to apply chain rule now. So dy by dx is equal to dy by d theta into d theta divided by dx. So you always have to flip it. So here dy by d theta is 2 sine 2 theta divided by dx by d theta. Remember, we take reciprocal, okay, of this value. This is dx by d theta, we take its reciprocal, okay. So uh, here we have is divided by, or you can write into d theta by dx would be 1 divided by 2. Let me take 2 common, so 1 plus cos of 2 theta, okay. This 2 is cancelled with this. Now in numerator we have sine of 2 theta divided by, this is 1 plus cos 2 theta, 1 plus, now cos 2 theta is basically 2 cos square theta minus 1. This is the identity from trigonometry, okay. In numerator we have 2 sin theta cos theta, sin 2 theta is 2 sin theta cos theta divided by 1 plus 2 cos square theta minus 1. It is cancelled out. So we have 2 sin theta cos theta, 2 sin theta cos theta divided by, this is 2 cos square theta, right? 2 cos square theta. So 2 cancelled out, cos theta. So we are left with sin theta divided by cos theta, that makes tan theta. Okay. So our dy by dx is equal to tan theta. This is, I guess, what we had to prove. In the question, if you see, the parametric equation of the curve are x is equal to 2 theta plus sine 2 theta and y equals to 1 minus cos 2 theta. So we have to find dy by dx in terms of tan theta. So we differentiate uh, both x and y with respect to t. So dx by d theta, sorry, with respect to theta, and dy by d theta, and then we apply chain rule here, right, to find out dy by dx, and we substitute the values. Remember, we have to take reciprocal of dx by d theta to make it d theta by dx, okay, and this is the final answer. So this is another example of parametric equation. Let's do another question, okay. Here is another question, which is x equals, okay, the parametric equations of the curve are x is equal to 4t divided by 2t plus 3 and y equals to 2 natural log of 2t plus 1. We need to find dy by dx in terms of t, and we need to simplify our answers and then find the gradient when x is equal to 1. So first part is x is equal to 4t divided by 2t plus 3 and y is this. So first of all, let's find dx by dt. So dx by dt, it's quotient rule, so that makes it 2t plus 3 whole square, that is 2t plus 3 denominator as it is, derivative of numerator minus numerator as it is, derivative of denominator, that is 2t plus 3, okay, which is equal to, now this is dx by dt, that is equal to 2t plus 3 whole squared, that is 2t plus 3 times 4 minus 4t into 2. So that is dx by dt is equal to 8t plus 12 minus 8t divided by 2t plus 3 whole square. You can cancel 8t and your dx by dt is equal to 12 divided by 2t plus 3 whole square, right? And similarly, y is 2 natural log of 2t plus 3. So your y is equal to 2 natural log of 2t plus 3, right? So now dy by dt is equal to 2. Derivative of natural log is 1 divided by 2t plus 3 into derivative of angle, that makes it 2. Okay, so it's 4 divided by 2t plus 3. This is your dy by dt. Okay, so we have dx by dt, dy by dt. We are going to apply chain rule now. So that states that dy by dx will be equal to dy by dt into dt divided by dx. So we have dy by dt, that says 4 divided by 2t plus 3 into dt by dx. Now this is dx by dt, so we need to take its reciprocal, that is 2t plus 3 whole square divided by 12. So now we need to simplify this expression. Dy by dx is equal to, you can cancel it out, 4 3s are 12, so this is 2t plus 3 divided by 3. Now this is your dy by dx given in terms of t. Now if you observe in the beginning of the question in part B, find the gradient of the curve where x is 1. So now they have given x as 1, so x is equal to 4t divided by 2t plus 3. So when x is 1, that is 4t divided by 2t plus 3. So we cross multiply. 2t plus 3 is equal to 4t. So 3 is equal to 2t. 3 by 2 is value of t. So at the end it is x is equal to, just a minute, it's 2t plus 3, 2t plus 3, in numerator we have 4t, so that is 2t plus 3 is equal to 4t, and then 3 divided by 2 is value of t, what we get. So 3 divided by 2, we are going to substitute it here. 3 divided by 2 plus 3 divided by 3, and this is your final answer. 6 divided by 3, that is equal to 2. So your dy by dx or gradient is equal to 2 g, right? So have a look in this question. We had, this is a question that states parametric equations of the curve are this and this, and we need to express. Just a minute. Sorry, just a minute. Yes, so you find dx by dt and then dy by dt. You substitute it here at t equals to 3 by 2. This is your dy by dx at the given point, right? So let's move to next question now. Okay, here is another question that states that the parametric equations of a curve are x is equal to e power minus t cos t and y equals to e power minus t sin t. So we need to show that dy by dx is equal to tan of t minus pi by 4, right? So here you go. First of all, we need to find dx by dt, that is simply dx by dt, a product rule. Okay, so first function as it is, derivative of second plus second as it is into derivative of first. So you simplify it, that makes it minus e power minus t sin t minus e power minus t cos t. So what you can do is you can take minus e power minus t common, that remains sin t plus cos t, right? That is your dx by dt. Now, uh, next we need is dy by dt. So, dy by dt is, you have y equals to, again, y equals to e raised to the power minus t sin t, okay? And we have to apply product rule. So by the way, I also applied product rule here. So derivative of u dot v is u dot v prime derivative plus v dot u prime. Okay, this is product rule we use. So this is your u, this is your v. So dy by dx now, first function as it is derivative of second plus second as it is derivative of first, e power minus t. So if you take e power minus t common, that is equal to cos t minus sine of t, right? That is your dy by dt. Now this is dx by dt, this is your dy by dt, and now we apply a chain rule here, okay, to find dy by dx. So that is dy by dx is equal to dy by dt times dt by dx. So dy by dt is e raised to the power minus t into cos t minus sin t into, that is basically dx by dt, but here we have to take reciprocal of it, dt by dx. So 1 divided by e power minus t, so it's 1 divided by e power minus t into, that is sin t plus cos t, that is sin t plus cos of t. Okay, so next is, you can cancel it out, so that remains is sin t minus cos t divided by sin t plus cos t. Okay, so now what we are going to do is, since in question we need to express it tan t minus pi by 4, so how can we make it tan? Okay, so if I divide numerator and denominator with t, okay, and I have used this minus to shuffle this their places here. So if you divide it sin t by cos t minus cos t divided by cos t whole divided by sin t divided by cos t plus cos t divided by cos t, right? This is cos t. Done. And now we have sin divided by cos is your tan t, that is equal to tan of t minus 1 divided by sin over cos is tan of t plus 1. Now in this particular question, you should remember that tan pi by 4, what it was? 1. I'm using this because in question we have pi by 4, right? So wait, here we go. I can express tan of t minus tan of pi by 4 divided by 1 plus tan t tan pi by 4, because tan pi by 4 is 1, so it can be expressed in this way. And we can use addition formula for tan, that is equal to tan t minus pi by 4. Okay, so that is what is required. So that is your dy by dx. It's very important to recall addition formula of tan. So if you remember, tan of a minus b was equal to tan a minus tan b divided by 1 plus tan of a tan of b, right? So we basically using that formula for this. Okay, so this is how we differentiate parametric equations. Parametric equations are basically given in the form of parameters. So see you in next video. Till then, Allah Hafiz. You take care.